All right, let's take a look at how we determine whether something's symmetric to the x, the y-axis, or the origin. So if you want to determine if you have symmetry to the x-axis, right? Then you're going to have to substitute in negative y for y. If you want to determine if you have symmetry to the y-axis, you're going to substitute in negative x for x. And then for symmetry to the origin, you want to substitute both. Negative x for x's and negative y's for y's. So let's see this in action, okay? So I'm going to go ahead and substitute a negative y for the y in the original equation. All right, and I'm going to do all the math I can to try to make this look like the original, okay? So if we take the y, negative y, and we square it, so think about what a negative y times another negative y means. We know a negative times a negative equals a positive, and we know a y times a y equals a y squared. So we can replace this negative y squared with a positive y squared. And if you stop there, you can see it matches the original. So since it matches the original, we're going to go ahead and say it is symmetric to the x-axis. Or let's just put a check mark on it, okay? All right. Now, if we plug in a negative x for the x in the original equation at the top left of the screen, we kind of get the same thing, because if we take a negative x and we multiply it by another negative x, well, negative times a negative is a positive, and an x times an x is an x squared. So we're going to replace this with an x squared. And you can see again, that does match the original exactly. So that's going to be symmetric to the y-axis too. Now you can see from all the work that we've done that if we substitute a negative x for the x and we substitute a negative y for all y's, okay, we know we end up with this from the last two examples that we did. And this again matches the original. So we're going to go ahead and put a check on this one. So it turns out that we're going to say it's all of these things. Okay, it's all of these things. And you'll find out later on this is actually an ellipse. And so ellipses look like, you know them as ovals. But if you have an ellipse centered at the origin or an oval centered at the origin, then your oval is going to be symmetric to the x, symmetric to the y. And if you flipped your paper upside down 180 degrees, right, then it would also look the same. So that's why we're going to check all of them on this one. All right, great. So this was question number 6 that we were looking at. Thanks for joining me, you guys.